Hello friends, let's solve this problem. 1 mole of SO3 was placed in 2-liter vessel at certain temperature. The following equilibrium was established in the vessel, that is 2SO3 gas giving 2SO2 plus O2. The equilibrium mixture reacted with 0.2 mole of KMnO4 in acidic medium. Find the value of Kc. So it's very simple. We have to calculate the equilibrium amount of SO2 because SO2 will only react with KMnO4. So SO2 is in plus 4 oxidation state, will go to plus 6, that is sulfate ion, and KMnO4 plus 7 will go to Mn2 plus. So there will be redox reaction between SO2 and KMnO4. So with that redox reaction, we can figure out the amount of SO2 at equilibrium. And once you got the mole of SO2 at equilibrium, you can figure out the moles of O2 as well as SO3, and then you can find the Kc expression. So let's start. First of all, we'll write this equation. Okay, now at t equal to 0, we have 1 mole of SO3 and there is no mole of SO2 and O2. As the reaction will proceed, let's say at equilibrium x mole of SO3 is reacted. So it will be 1 minus x left. This is 2 mole, this is 2 mole. Okay, coefficient is 2 is to 2, so it will be x. And this is half 1 coefficient, so it will be x by 2 mole formed. Okay, so simply we have figured out, we have used here mole analysis. Like 2 mole of SO3 will give me 2 mole of SO2. So it is x mole reacting means x you will get. But 2 mole of SO3 will give you only 1 mole of O2. So x mole will give you x by 2. Simple. After that, we'll write the redox reaction. We don't have to write the balanced redox reaction here, simply rough. That is SO2 plus KMnO4 in acidic medium will go to Mn2 plus and sulfate ion. Now SO2 sulfur is in plus 4 oxidation state and SO4 sulfur is in plus 6 oxidation state. So valency factor will be 6 minus 4, that is 2, right? Similarly, KMnO4 plus 7, it is going to plus 2. So here valency factor of KMnO4 will be 7 minus 2, that is 5. Okay, so we'll write the valency factor. After that, we'll just write the law of equivalence, that is number of gram equivalent of KMnO4, that is number of moles into valency factor of KMnO4 equal to number of mole of SO2 into its valency factor. This mole of KMnO4 is given to us, that is 0.2 mole. So we'll just write it and we'll figure out the value of mole of SO2. So we are getting mole of SO2 as 0.5 mole. Now we'll put this in this equation. We'll get the equilibrium amount of SO2, O2 and SO3. So we'll write the Kc expression now. Kc expression will be what? The product concentration, okay, raised to its stoichiometric coefficient. Okay, already you know how to write. Now the amount we can write. SO2 amount is x, that is 0.5. O2 will be 0.5 by 2, that is 0.25. And this will be 1 minus 0.5, that will be 0.5. But these are moles, okay, and we have to write their concentration here in this expression. So we have to divide by the volume, and volume of the vessel is here 2 liter volume. So 2 liter you have to divide by all. So here it will be concentration will be mole by 2 whole square. Similarly, O2 mole by 2 divided by SO3 mole by 2 whole square. This will be cancelled out and the Kc value will be 0.125. So that is the final answer. So the correct answer should be C. Thank you.